What's up guys, I'm Ryan, I'm a tutor in the Econ Tutoring Center. I'm going to go over another video about the Solo model, and this time I'm going to show what happens when we have changes in our parameters S and D. Remember that language and notation varies by professor, so always check to be sure that the language we're using is the same as your professor's. Alright, so like I said, I'm going to talk about what happens. There's another video where I go over kind of the basic Solo model and how we find our steady state level of capital, savings, and output. So now I want to show what happens to that steady state level of capital. Remember, in this case, it's just where the depreciation on capital is equal to the amount that's being reinvested in it. So this would be your steady state level of capital. Remember, in this model, we're talking about physical capital is graphed here against output. So your steady state level of physical capital, which is your K star, right? And I'm going to call this K star 1. And our Y star and our S times Y star, which is our savings level and output level at our initial steady state. Okay, so let's look what happens when, let's say, the depreciation rate on capital goes up. So now all of a sudden capital is depreciating at a faster and faster rate, i.e. The slope of this line increases. Because this is just a straight line with a slope of D, our depreciation rate. So if that goes up, so capital is depreciating faster. That wasn't a great line, but basically we'll end up with another line, now D prime, okay, where D prime is bigger than D, right? So the depreciation on capital went up. So capital in every period, we're losing more value in capital from one period to the next. So obviously now we can see with the same saving rate and the same production function, we're going to end up with a lower level of steady state capital. So I'll call that K2 star, which is going to correspond to obviously a lower savings, Y2 star, and a lower total steady state output, right? And so the intuition behind that is that, if we're losing more capital every period, then we're not going to be able to maintain as high of a level, right? Because we're losing something, so obviously we're going to have less output and less savings and less capital as before. So it's still a steady state, like everything is still in equilibrium everywhere, but the problem is that obviously society or output would be better off if capital didn't depreciate as much. So that's where the intuition behind these numbers being the way they are. Alright, so I'm going to erase these changes I made. Okay, so now we're going to look at what happens when the saving rate changes. We talked about earlier what happens when the depreciation rate on capital goes up, but now we're going to see what happens if at every period people decide to save a larger fraction of their income, which means that S goes up. So let's say that S goes up to some number S prime, which is bigger. Right, then we're going to end up with maybe something that looks like this. This is S prime, A, F, of K, H, right? We still have the same production function, so this doesn't change. We still have the same depreciation rate of capital, so this line here still stays the same. But now we're going to end up with a higher steady state level of capital, right? So we end up with K2 star here, a higher steady state output, so Y2 star, and of course a higher S, Y star. So the idea is that in the steady state, if people start exogenously saving more of their income, and when I say exogenous, it's something that doesn't happen inside the model. Once the model and all these parameters are fixed, nothing's going to make S change. But if something changes in people's preferences, so we say an exogenous change, then we end up with these changes to our steady state variables, right? So obviously people are going to save less, or save more rather. So S times Y goes up. We also see that K star is going to go up, and our steady state level of output is going to go up. So hopefully these changes gave you a little bit better idea of how the Solo model works and what maybe the difference between the exogenous change. Remember, both the change in the depreciation rate D and S are what we call exogenous changes. So it gave you a better idea of what that means and how steady state, capital, and other variables react with those changes. If you have any other questions, come to the Econ Tutoring Center.